All right, so we are looking at Unit 4, Learning Set 8, which matches 5-8 in your workbook, Driving Safety Data. So today what we're going to be learning is calculate reaction time and distance in the English Standard System, which, remember, the English Standard System is like feet, inches, miles. We're going to also calculate and use the braking distance in both the English Standard and the metric system. And the metric system is like kilometers, meters, those type measurements. And the last thing is calculate and use the total stopping distance in both English Standard and metric systems. Okay, here's some vocabulary. Okay. Some of our vocabulary is reaction time, and that is basically the average of when an alert driver takes from approximately 3/4 of a second to 1.5 seconds to switch from the gas pedal to the brake pedal. So that is an average for someone who's alert. If you're not paying attention, like you're looking at your cell phone or you're staring off into space, and it might take a little longer if you aren't alert. Reaction distance, this is what we call the distance a car travels during reaction time. And that is the reaction time is the time it takes you to take your foot off the gas and put it on the brake. And braking distance is the distance the car will travel while braking to a complete stop. So here, let's do a little math with this. Okay, here's some facts. Most people think they can stop on a dime. They think if they hit the brakes, they're going to stop within a couple of feet. So let's look at a couple of facts. Well, we know that there are 5,280 feet in a mile. We know a car traveling 55 miles per hour covers 55 miles in 1 hour. So let's do a little math now. If a car is traveling 55 miles and it covers 55 miles, if we multiply that times the number of feet in each mile, that means a car can travel 290,400 feet in 1 hour. So we're going to break it down a little bit now. Let's take your feet in 1 hour and make it into feet in 1 minute. So we could take our answer and divide it by 60, because there's 60 minutes in an hour. That means we would go 4,840 feet in 1 minute. And let's break it down even further. How many feet is it going to go in 1 second? So there's 60 seconds in a minute. So we're going to take this 4,840 feet and divide it by 60. So in 1 second, a car that is traveling 55 miles an hour goes 80.67, or approximately 81 feet. Let's think about this, what they said the average. They said the average is 3/4 second reaction time and 1.5 seconds reaction time. So let's make both of them into a decimal because it'll be easier. So 3/4 is equal to 0.75 and 1.5 is equal to 1.5. And let's set up a ratio. Okay, so on our ratio, we want to know how many feet per second. Okay, so we determined on the previous slide that you can go 81 feet per each second when you're going 55 miles per hour. Okay, and if our reaction time was 3/4 of a second, then we could figure out how many feet we would go. So that 7.75 seconds would go on the bottom, X would go on the top, and then we would do our cross multiplication. So x equals 81 times 0.75. X equals 60.75. So even if you react really quickly in 3/4 of a second, you've still gone 60 feet if you were traveling at 55 miles an hour. Let's look at it for 1.5 seconds. So that would once again be the 81 over 1. And our other fraction would be 1.5 is the second, which is on the bottom. So that would be x on the top. Do our cross multiplication. X equals 81 times 1.5. X equals 121.5 feet. So your stopping distance, or not your stopping distance, your reaction distance that your car can travel at 55 miles per hour is going to range anywhere from 60 to 121 feet. Okay, now this is for 55 miles an hour. Typically, a rule of thumb that a lot of people use is your speed that you're traveling, your miles per hour, is equal to the feet that your car will travel while you're reacting and having to move your foot from the gas to the brake pedal. So in this first example, what's the reaction distance for a car traveling approximately 48 miles per hour? A conservative rule of thumb is the reaction distance is that the car travels about 1 foot for each mile per hour speed. So in this case, if you're traveling at 48 miles per hour, your reaction time at 1 second would have your car traveling approximately 48 feet. Okay, now we're going to look at braking distance, and there's a general formula for braking distance, and that is s squared divided by 20. Or an equivalent formula would be the quantity 0.1 times s squared times 5, where s represents the speed of the car. And your result would be how many feet you travel when the car is traveling at s speed, and that is how far you go after you've hit the brake. Okay, so what is the approximate braking distance for a car traveling 48 miles an hour? So we're going to use both to show you that both formulas give you the same thing. So s squared divided by 20, and we said that s is equal to how fast you're going. So s is going to be 48. Plug it in. 48 squared divided by 20 gives us 115.2 feet. That is how far your car travels once you've hit the brake. So using the other formula, the quantity 0.1 times 5 to squared times 5, put 0.1 times s squared times 5, put in 48 for s, and we get the same result, 115.2 feet. So you could really use either formula. You don't have to use it twice. You pick one of the formulas to use. So what this is telling us is that once the brakes are applied, a car traveling at 48 miles per hour will come to a complete stop after the car has traveled approximately 115.2 feet. All right, so now we want to figure out what our total stopping distance, how long from the time we react to the time that the car actually stops after hitting the brake. So that is going to be a total of your reaction distance plus your braking distance. So to continue what we were doing, Rachel is driving at 48 miles an hour. So that is going to be our speed on a one-lane highway. She sees an accident directly ahead of her about 200 feet away. Will she be able to stop in time? So we need to take and figure out what our reaction distance is. And we know that that's the same as the miles per hour. Therefore, our reaction distance is 48 feet. Our braking distance would simply be using the braking distance general formula, plugging in our miles per hour for S, dividing by 20, and we get 115.2 feet. So to find our total stopping distance, add them together, the 48 plus the 115.2, and we get 163.2 feet. Now the question asked us, will she stop in time for an accident that she sees 200 feet away? So remember, reaction distance is from when you see it until you hit the brake. Okay? And braking distance is after the brakes are engaged. So the total stopping is going to be a combination of both. Okay? So in this case, Rachel is going to be able to stop in time and not run into the accident because her 163.2 feet is less than the 200 feet that the accident was ahead of her. All right, last example. Desiree is traveling through Canada. The speedometer in her rented car indicates kilometers per hour, and all of the road signs give distances in kilometers. And she knows that 1 kilometer equals 1,000 meters, and 1 meter is a little more than 3 feet. Determine Desiree's stopping distance if she's traveling by 88 kilometers per hour. So one thing to keep in mind is that 1 kilometer is approximately 0.6213712 miles. Okay, and you can set up a proportion like we have in the past where let's put kilometers on top, miles on the bottom, and our proportion would be 1 over 0.6213712. And then if she's traveling, her speed is 88 kilometers per hour. The 88 is going to go on the top of our fraction, x on the bottom. Do our cross multiplication. We know we're just going to multiply those two numbers, 88 and 0.6213712. We get 54.680648. So that would mean that 88 kilometers per hour is approximately equivalent to 54.68 miles per hour. So when you're looking at a metric system, the numbers kind of fool you into think you're going faster than you are because those units are all based on 10. All right, so next we want to evaluate the stopping distance. Okay, so our stopping distance would be our reaction distance. Remember, this is simply our speed written as feet. Okay, and then we want to figure out our braking distance. And remember, on our braking distance, we use that formula s squared divided by 20. Put in our speed. Our speed in this case, we're using our miles per hour. And the reason that we had to convert it to miles per hour is because these formulas are based on miles, on a speed and miles per hour in feet. That's how they formulated the braking distance formula. So we would not get the same answer, and we would not get a correct answer if we had kept the units in kilometers. And that is why we converted the measurements. So when we add those together, we end up with 204.17512 feet. So now to convert it back into meters, which is the unit of measure she was looking at, now that we've got our result, we would use the conversion of 0.30148 meters per foot. Okay, so we would know, you could also use this as a proportion if you want. You could say meters to feet, which would be 0.3048 divided by 1. And then we know our braking distance in feet, so that would go on the bottom, 204.17512, x on the top. And then when we do our cross multiplication, you can see that our two numbers to convert, we would actually be multiplying and not dividing. So we would multiply our stopping distance times our conversion, and it would take her about 62.23 meters to stop.